Hey y'all, my name is Sarah and today I'm going to walk you through the 2009 AP Calculus AB FRQ, question number 5. This video is designed to help us prepare for the AP Calculus exam. Are you super excited? Let's get started. First, let's go over a few very important details. This question is on the non-calculator part of the exam, so put away your calculator. Seriously. You do not want to have your test canceled. Another thing, this video is going to be very detailed in order to help us truly understand the problem. But in order to make things a little clearer, I have boxed the important stuff, or the work you really need to show on the AP exam, in orange highlighter. Finally, I highly recommend that you have the FRQ out in front of you, because in this video I'm only going to walk you through the work. I won't actually be showing you the FRQ. I'll link the 2009 FRQ in the description so you can look at it while you watch this video. Okay, now that we're done with that nitty-gritty stuff out of the way, let's get to doing some super fun math. This problem is a gift. It gives us a whole table of values, and for part A, all we have to do is find the slope between the 2 points. It tells us to find f prime of 4, but since we don't have the actual function, we'll have to use a table of values. The best we can do is find the slope between f of 5 and f of 3. Basically, we're going to find the average rate of change instead of the instantaneous rate of change. To do this, we find the algebra slope between the points 5, -2 and 8, 3. We do this through f of x2 minus f of x1 over x2 minus x1. Finally, we get that the slope is -3. Very roughly, f prime of 4 equals -3. Part B asks us to find the integral of 3 minus 5 times f prime of x from 2 to 13. This looks super complicated, but it definitely doesn't have to be. Remember that in this case, if you take the integral of a derivative, you just get the original function. So let's split up the integral and solve. The integral of 3 is 3x, and the integral of 5 times f prime of x is 5 times f of x. Now, we can plug and chug. Plug in x equals 13. For x equals 13, we get 3 times 13 minus 5 times 6. Now plug in x equals 2. We get 3 times 2 minus 5. Subtract what you got for x equals 2 from what you got for x equals 13. Our final answer is 8. Part C asks us to find the Riemann sum of the function using left endpoints. Do you remember Riemann sums? I do, and they definitely weren't my favorite part of calculus. It's okay though, we already have the table of values, so really all we have to do is plug and chug. Let's draw an imaginary graph of f of x so that we can visualize how Riemann sums look. Basically, all we're doing is just splitting up the area under the curve using rectangles. That's simple enough. Based off of our table of values, we know that we're going to have 4 different rectangles. Because we're using left endpoints, we will be using the leftmost y value as the height of the rectangle, and the difference between the two x values will be our width. In some cases, you would be able to multiply one delta x by a bunch of y values. In this case, however, the change in x values are not all the same, so we have to find the area of each individual rectangle. It's a common mistake to try to multiply by just one delta x, and it works in some cases, but only when there's a uniform delta x. For rectangle number 1, we know that the height will be f of 2, or 1, because 2 is the leftmost x value of this rectangle. The width is the difference of the two x values, which are 3 and 2, so the width will be 1. Width times height equals 1. For rectangle number 2, the height is f of 3, or 4, because the 3 is the leftmost x value of this rectangle. The width is the difference of the two x values, which are 5 and 3, so the width is 2. Width times height equals 8. For rectangle number 3, the height is f of 5, or -2, because 5 is the leftmost x value. Wait up, the height is negative? That's okay. There is such thing as negative area, and it's really important that we include the negative, because the problem asked us for area, not displacement or absolute value of the area. Anyway, The width is the difference of the x values, or 8 minus 5, which equals 3. The height times the width is negative 6. Make sure to keep the negative. Finally, for rectangle number 4, the height is f of 8, or 3, because 8 is the leftmost x value of the rectangle. The width is 13 minus 8, which equals 5. The width times the height is 15. Now all we have to do is add all the area values we got together. Make sure the negative 6 is still negative. We get that the total area equals 18. 3 down, 1 to go. For part D, in the first part, we're asked to show that f of 7 is less than or equal to 4, knowing that f prime of 5 is 3 and f double prime of x is less than 0 on the closed interval 5, 8. Basically, we know that f of x is concave down, and at x equals 5, the slope is positive. Let's draw a conceptual graph of f of x to understand this better. We can see that the curve is concave down, and the tangent line, since it has positive slope, will rest above the curve. Therefore, we find f of 7 based on the tangent line, and we get an overestimate. That'll be really important in proving our answer. Okay, here's our game plan. We'll find the equation of this tangent line, then plug in x equals 7 to get f of 7 according to the tangent line, and finally, we'll explain our answer. Since we know that the slope of the tangent line is 5, we can find the equation through point-slope form. Y minus y1 equals m times x minus x1. For our point, we must use 5, negative 2 because that's the point at which there's a tangent line. We plug in chug, and finally we get the equation as y equals 3x minus 17. Now we're going to plug in x equals 7 to the tangent line equation. We get that y equals 4. That's good, because that's the answer we were supposed to get. Now it's time to prove it. We know that since f of x is concave down, the tangent line lies above the curve, making our answer, given by plugging in x equals 7 to the tangent line equation, an overestimate. Awesome! Therefore, f of 7 must be less than or equal to 4. Now for the second part of D. We're almost done with this problem. This part asks us to use a secant line to show that f of 7 is greater than or equal to 4/3. Wait, hold the phone. What the heck is a secant line? I did you a solid and Googled it for you. It's basically just the average rate of change line between 2 points on a curve. As you can see on this handy-dandy graph, we're going to be using a line that connects the two endpoints at x equals 5 and x equals 8. So, when we find the f of 7 based on this secant line, it'll be an underestimate this time, because the curve is concave down, and therefore the secant line lies below the curve. Time for game plan part 2. We're going to need to find the equation of the secant line, then find f of 7 through that secant line equation, and finally explain our logic. For the first part, we know for sure what the two endpoints are, so our job becomes easy. We find the algebra slope between the 2 points, and we get 5/3. Then we plug in one of the points. I used 8,3, but it doesn't really matter which one you use. And we get that the equation is y equals 5/3 x minus 31/3. Then we plug in chug. After plugging in x equals 7, we get that f of 7 based on the secant line is 4/3. All we have to do now is explain. Now for our explanation. Because f of x is concave down, we know for sure that the secant line lies below the curve on the closed interval 5, 8. Therefore, the answer that we got by plugging in x equals 7 to the secant line equation is an underestimate. So, f of 7 must be greater than or equal to 4/3. Well, that wraps up our lesson. Thank you so much for watching. I've linked some extra practice down below in the description. Best of luck to you on the AP exam.